Okay, let's start the last recording, or this recording, not the last one. Sorry, it's not going to be the last one. That's your spring semester 2018 review, part 4. Okie dokie, so let's look at this. We're starting at problem number, I don't even remember what problem I'm starting at, number 60, where we can use exponent tables. So, when you see, like, say, some number and there's an exponent, you notice that the n or the x or whatever as an exponents, then make sure you have exponent tables, like say 8 to the 0, negative 1, negative 2, negative 3 power 8, 1, 2, 3, like that. So that way when you see something like this and you see 1 over 4096, you would be able to tell that that is 8 to the negative 4 power. And so then you can, once you've said that those two are like both base 8, then you can drop the base and say 7, 9 minus 4 equals negative 4 and then solve. But the key there is you gotta have an exponent table. So make sure like you have your exponent table, and you can see the answer there is 5 sevenths. But make sure you have an exponent table that reflects, and we've had this before, like 2, 3, you can do 4, you can do 5, you can do 6, you can do 7, you can do 8. Well, fine. Yeah, let's just do 8. And you can do 10. I seriously doubt you need to go that high. But the important part is that you go from, like, say, 2 to the, go from the negative 6 power to the positive 6 power. Up and down. Okay? So make that table. It might be beneficial, even if it is only for a couple of problems. Number 61, that one you should be able to recognize 625 is 5 to the 4th power. So I can replace the 625 with 5 to the 4th power. Then I have the same base. So I can get rid of the 5 and say 6n plus 5 equals 4, and then subtract and divide and get my answer to be negative 1/6. And there you go. 62 and 62 through 65, you're just rewriting. So you should remember how to rewrite. Don't forget, it's log base answer equals exponent. Or if it's in log form, the base with the exponent, because the exponent is what it's equal to, is equal to the answer. So kind of keep in mind that when you rewrite it to logs, you've got a base, which is the big number. You've got it equal to an exponent. And it's log base answer. So notice how I'm kind of rewriting that is equal to an exponent. Okay? And if you're going the other way, you've got a big base equal to an exponent. That's big base E. I don't even know how to say it. Base exponent equals answer. There we go. Base exponent answer. And you can kind of see where those are located. So that should hopefully make those easy. Alright, the first two on this one, 66 and 67, those you can type in the calculator. And you should know how to type those into the calculator. If not, well, just God help you. Anyways, these, 68 and 69, you can rewrite them. You've got to remember, this is the base, this is the exponent, and technically this is the answer. So if you rewrite it like that, you can say, 27 to the 8/3, well, then that will give me n, right? And then if that gives me n, then I can go back and then say, whoops, that was a mistake, hold up. So then I can go ahead and say that is 6,561. Same thing here, 4 to the 3rd power is 64. So basically I rewrote them into exponential form and then typed them into the calculator to find the answer. 70 through 72, it helps to know your log properties. Don't forget, to be able to get rid of a log, you have to have it down to 1 log on each side. When we add, we can multiply the numbers that are with the logs. So 2 log base 2 of 2 plus log base 2 of a means I can rewrite it as log times base 2 of 2 times a. Because plus means I can multiply. Now they're the same base, same log, so I can get rid of those logs and say 2a equals 13 and divide 13 by 2 to get an answer of 13 over 2. Number 71, I can do the same thing, but when I'm minus, I need to remember that it's going to be divide. So there I'm saying it's divide. There's other ways that some of y'all have done it, which will work too. But x plus 2 over 2 equals log 5, 4. And then I can drop it and say x plus 2 over 2 equals 4. And then to solve, I times 2, subtract 2, and you would have your answer to be 6. And so there you go. Not that bad. See, some of these, you can kind of do easily. Okay, so on number 72, how do I get rid of the 3? Well, remember, logs and exponents are opposite of each other. So if I put log 3, because that was what the base is, the log 3 and 3 cancel each other out, leaving me the y. And then all I got to do is type in the calculator log 3 of 40, and when you do, you would get an answer of 3.3578. I know it says round to 4 decimal places, but guess what? You'd probably be able to guess that just from looking at the answer choices on a multiple choice test. I don't know why that would even be in the directions, but whatever. Okay, so 73 and 74, how do I get rid of e's? Don't forget, natural logs get rid of e's, but get the e by itself. In other words, I need to get this 13 over to the other side, add 13, then I need to get rid of the 5. So now I've got e to the x equals 23 over 5. Now when I've got it down to just ex, I can go ln, that's an n, trust me, that's an n. ln, that's an n too. There we go, that looks more like an n. Anyways, and the e and the ln would cancel each other out, and then I could type in the calculator what's ln of 23 over 5, which would be 1.5261. Or 1 and 5,261 10,000ths. 74, same thing, but I'm going to subtract the 8 and then divide by 7. So I subtract the 8 and then divide by 7, and I get e to the 5x power is equal to 22 over 7. Once you do that, keep in mind that once you do the natural log, you still have to get rid of that 5x. So you still have to divide by 5. So I have here 5x is equal to 1.11451. Divide by 5, and I get x is equal to 0.2290. And there you go. So those are that's pretty easy. Now let's look at some simplifying with the fractions. Oh no, we got to the fraction stuff. Rational expressions. Hey, this looks like what we've just been covering. Imagine that. So how do I do these type of problems like on number 75? Well, let's just put everything together. Okay, this is times. So this is what I did. Okay, I said 37 times 3 is 111. So I multiplied the big numbers. P4, Q, I can't even read anymore, Q2, and then R minus 8 to the first power. Notice I put that as with an exponent of 1. 5 times 6 is 30. P3, Q5, R minus 8 to the third power. Now, I'm only putting these in order so I can have things over each other. Now, the 111 over 30, I would type in the calculator. So I would type this into the calculator and see what it gave me. And it gives me 37 over 10. And then with the exponents, just start subtracting. You don't even have to worry about like what letters or whatever. Just start subtracting the exponents. 4 minus 3 is 1. So that means that's P1. And since it's the bigger numbers on top, it stays on top. 5 minus 2 or 2 minus 5 is negative 3. But since it's negative, I got to move it down to the bottom. So that would be Q3. 1 minus 3 is negative 2. So that means I would move it down to the bottom and say just 2. R minus 8 squared. And that's it. There's your answer. Bada bing, bada boom. There you go. Not that bad, right? So you can do the same thing on 76. I would multiply across, like try to join everything together. And then like multiply across, simplify your numbers. So 12 times 3 is 36, x1, y2, 2 times 4, 24 is 48, x3, y, should be y1. Okay, so 36 over 48, the calculator would tell you is 3/4. 1 minus 3 is negative 2, so that means the x has to go down to the bottom to become x2. And then y2 minus y, or 2 minus 1 gives me 1, but it would be on top because it stayed positive. Remember, if you get like, when you subtract these two and you get a negative answer, or like you're saying the top one minus the bottom one, because that's how you can get these, because when we divide, we subtract exponents. If the answer is negative, leave it on the bottom, and then make it positive. Number 77, I'm going to hit play, and I'm going to do the same thing. 12 times 31, x, y squared. 16 times 24, x cubed y. And you can see the numbers I get when I say 12 times 31 and 16 times 24. And then, again, 372 over 384 would be 31 over 32. And then I subtracted. 78, don't forget when you divide, you actually flip the fraction. So notice how this, if you look at this, I've now flipped. Instead of saying 31x5y over 22a7b3, I'm now going to say 22a7b3 over 31x5y. So when I multiply this, 5 times 22 is 110. And then I've got all these x, y's, a's, and b's. 2 times 31 is 62. And then again, I got all these y's, x, b's. 110 over 62 is 55 over 31. 2 minus 5 is negative 3, so that means the x goes on the bottom. 3 minus 1 is 2, so the y goes on top. 7 minus 5 is 2, so the a goes on top. 3 minus 4 is negative 1, so the b goes on the bottom. And there you go. Plain and simple, that's how you get that answer. Alright, number 79. Okay, same thing. I'm going to let it play through. Just remember that when you divide, you actually multiply by the reciprocals. So I'm going to actually flip the 45a9, put it on top, and the 53a plus 3, put it on the bottom. And now I need a factor. A plus plus is a plus plus. Two numbers that multiply to give me 6 and add up to 5 are 3 and 2. When I see a squared minus a number, I see if I can take the square root of it, and the square root of 81 is 9, so that means it's plus minus 9. And then I can join the 45 and the a plus 9, the 53 and the a plus 3. And again, I would technically multiply 3 times 45. Okay, I'm crossing out the a plus 3, sorry, and the a plus 9s. So now what can I do to simplify? And you know, maybe by this point you would be able to tell that the answer is like a plus 2 over a minus 9, and then figure out what the numbers are in front. Anyways, 3 times 45 is 135. 5 times 53 is 265. And then I would type those into the calculator. 135 divided by 265 is, I don't remember now, let's see what it says. 27 over 53. And there you go. So that might be something you could do. More than likely, with just the a plus 2, a minus 9, you'd probably already have the test. But you'd have the answer from the multiple choice. All right. Number 80 and number 81, I would rewrite it, and you're seeing how I would rewrite it. Divided by the numerator divided by the denominator, and then that tells me that I can multiply by flipping the fractions, which is what I'm doing. And then from there, I'm doing the exact same thing I normally do. 16 over 19. 1 minus 4 is 3, negative 3, so that means the g would go on the bottom. 8 minus 2 is 6, positive 6, so the h would stay on top. Number 81 is going to be very similar. I don't know if that should have been x plus 1. I don't remember. Whatever. And again, flip-flop it. You got to remember, you got to flip-flop. This one is greatest common denominator, so I would take the 3 out. That will leave me x squared plus 1, which I can take the square root of 1, which means I can go x plus, x minus the square root of 1, which is 1, over x times flip-flop. Now on the bottom one, or the flip-flop one, I can take out an x, so that leaves me with x parentheses 2x minus 5, 3 over x squared plus 11. What crosses out? The x's cross out, the 3's cross out, and that's pretty much it. And there's my answer. I'm betting that I'm going to have to fix these like when I take the test, because I like y'all to show me the individual elements and not say all of that combined, like say some of y'all have been probably trying to do with your little photo math, thinking I'm a stupid idiot. But there you go. And yes, there will be no phones allowed, or you will have your phones face down constantly. If you want to pick them up during the semester exam, I will automatically give you a 0. Leave it on play or shuffle, and we'll talk about that later. Oh, let's look at the next ones. Adding and subtracting. Again, what I would do is I would give them to you in the individual elements. So, like instead of saying 4x squared minus 36, I would tell you it's 2x plus 6, 2x minus 6. And then you could tell me, okay, the greatest common denominator is 2x plus 6, 2x minus 6. So the first fraction already has that, so I can just put the 5. But the second fraction is missing the 2x minus 6, so that means I need to multiply the 4 by 2x minus 6. And that would give me 8x minus 30. I'm sorry, minus 24. And then I can combine my like terms. There's nothing to go with the 8x. 5 minus 24 is negative 19. Over the 2x plus 6, 2x minus 6, which is how I would give you the answer. And there you go for number 82. For number 83, I would do, again, same thing. Give it to you as 2x plus 3, 2x minus 3. And then you would notice that your greatest common denominator is 2x plus 3, 2x minus 3. So you need to multiply the 6 by the 2x minus 3 because that's what's missing. So that would give me 12x minus 18. And then you would combine your like terms and get 12x minus 17 over 2x plus 3, 2x minus 3 would be your final answer. So there you go, easy peasy, not a problem. Number 84, notice they already have the same denominator, so I could easily just combine like terms. You would have think those problems would have been before the 82 and 83, but hey, what would I know? Anyway, 7x plus 13x is 20x, and 9 plus 3 is 12. How is that different than in 85? There's a minus in between, which means then instead of saying 13 plus 7, you're actually going to say 13 minus 7, which would give you 6x. I'm going to let that play through because apparently I did a copy and it just literally just actually copies even my handwriting. So there we go. So 13 minus 7 is 6x. Notice I do nothing with the denominator. Once I know that they have the same denominator, I just combine like terms. So 13 minus 7 is 6x, 9 minus 3 is 6, and you're done. Why did I put minus 6? I have no clue. That would be a plus 6 because the 9 was bigger than the 3. Anyways, we're almost there for this one. Oh my goodness. That was 85, right? Okay, so now 86. That one, notice that you have a y plus 2, y minus 2, so the common denominator would be y plus 2, y minus 2, just getting what you get from both of them. So that means I need to multiply the 8 by y minus 2 because I'm missing that. So that gives me 8y minus 16 minus the 3y. So 8y minus 3y is 5y minus 16 over the y plus 2, y minus 2. And there you go. And there's your 86. So, hey, we're getting there. All right. So now we're getting to problems like 87, 88, 89, 90, 91 where we can solve. So here, how do I solve? Well, we find the least common multiple, and you will get a question that says, what is the least common multiple? In this one, it's just x minus 1 and 2. Okay, so if I multiply the first one by x minus 1, or the multiply by the least common multiple, that would get rid of the x minus 1, and I'd have 2 times x, which is 2x. There's nothing to get rid of in the second number, so that means I would multiply. Negative 1 times 2 is negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is going to be positive 2. And then the 2's would cancel out on the next one, leaving me 5 times x minus 1, which is 5x minus 5. 2x's cancel out because those like terms canceled each other out. I would move the 5 to the other side by adding, and then you could say divide by 5. And to get x is equal to 7/5. Alright, maybe I might give y'all some more problems on that later, I don't know, or we can talk about those. I'm looking at, like, say, 90 and 91. Those would probably be workable, but guess what? We get to omit 88 because it just would have been too hard to solve, or it would have been harder than necessary, and I think that's just kind of crazy for a semester exam. Notice on 89, the least common multiple is y minus 5, and that cancels out the bottoms, leaving me 5 equals y times, or minus 1 times y minus 5, which would become y plus 5. The y's cancel out, and since the y's cancel out but the numbers don't, that would leave me an infinite solution since the numbers are the same. If the numbers had been different, then it would have been no solutions. I will try to make sure nothing like that happens on the semester exam. Anyways, I'll finish these off, or finish off like this problems, like 90 and 91 on the next video. Hopefully I can finish off the rest of this video with the next video can finish off the rest of this review. We shall see. Anyways, that's it for today. Thank you so much for your time. Y'all been great. Y'all are awesome. Take care.